Don't know or no? You know. This is very important. We are talking about semiconductors. We don't know how these bands are forming. Okay, let's see this how the bands are forming. Okay, tomorrow we'll discuss if you take intrinsic semiconductor, how many electrons are available. Suppose if you take intrinsic semiconductor, these energy states are extending up to infinity. If you take these energy states are extending, suppose this is conduction band EC to infinity. Each state there is a electrons, right? Each state there is a electron. Here also in the valence band also there is a many states, many number of states. These also extending up to infinity. But each state some of the electrons are filled. We don't know how many electrons here. We don't know how many electrons are here. That is why we are going to estimate. We will estimate tomorrow how many electrons available. That is electron concentration or concentration of electrons and concentration of holes. That we will discuss tomorrow. But here today how the energy bands are formed. Anybody know? You know or don't know?
By electron density, sir.
Sorry. Suppose we are talking about suppose if you take silicon, the band gap is 1.1 electron volts, 1.12 something like that. If you take germanium, the band gap is 0.65 like that electron volts. Or if you take insulators, any insulators, the band gap is very high, right? Very high. That is greater than will suppose if you take silicon, so each electron in a shell, suppose this is 2s shell, and after that 3s or 3p shells are there. Okay, n is equal to 3. Here n is equal to 2 means 2s is there, 2p is there, like that. Okay, here electrons are revolve around the nucleus, right? Here also, if you take one more atom here, silicon, here also we are drawing number of shells. Okay, different shells. Okay, suppose this is n is equal to 3. Here n is equal to 3, we have 3s2 and 3p2, right? That means 4 electrons are available, right? 4 electrons available. So like that, if you bring these two closer, if you bring two atoms together very close to each other, these outer shells will interact. These outer shells, first the outer shell means n is equal to 3 shell will interact. That means electrons are interacting with each other. Or wave function, suppose the wave function is like this. Okay, wave function is like this. Wave function means, you know, we are bringing one more atom to close to first atom. This is first atom, this is second atom. It is also having some wave function. Okay, so these two wave function will interact. That means electrons are interacting with each other. Electrons are interacting with each other. That means they exchange, once electrons are interacting means they exchange the energy. They exchange the energy. First n is equal to 3 shell will overlap. N is equal to, like this, first n is equal to 3 shell will overlap. If you bring it to closer, the n is equal to 2 shell will be overlap like this. Okay, n is equal to 2 shell also. Second shell also overlap. First, last cell will overlap. After that, if you bring closer, again in the deeper cells also interact. That means energy will exchange between deeper electrons also. Once this wave function is interacts, they exchange the electrons, exchange the energy. Each electron having some energy state, right? Like this we have drawn earlier. Here also each atom having some energy levels. Energy levels, these two energy levels split into two energy levels, so see a example, just see one example to on. Suppose you have a two, okay, you are sitting in a one bench, right? You are sitting daily, you are sitting one bench. Okay, if you have some fight in between, what you will do? One person will sit one bench and other person will sit other bench, right? You got it, right? So earlier you are very close, you are sitting only one bench. Once there is a fight or there is some disturbance between you, you will sit in different bench, right? Here also electrons energy will exchange between them, and so the electron energies interact or exchange, the energy levels will split into a different energy levels. Suppose here we have taken 2 atoms. If you take 10 atoms, 10 energy levels will be there. 10 energy levels will be there. These energy levels are very closely separated. This we are calling a band. That we are calling a band. Like this, energy levels are forming in a semiconductor. Now we will see one more this by electronic configuration we will understand this. Just a second please. This may not come in exam, but if someone asks how the bands are forming, you have to you should able to explain. Okay, in silicon configuration 1s2, 2s2, 3s2, 3p2, right? 3p2, here 2p6 is there, right? Here how many valence electrons are there? Four electrons are there. If you draw one more silicon atom, 1s2, 2s2, 2p6, 3s2, 3p6. Here also 3p2. Sorry. Here 4. Here 4. We are bringing 2 atoms close together. That means here if you have one more, this is what? This is 3s orbital and this is 3p orbital. Okay. How many electrons are available in 3p orbital now? Both, if you take we brought the 2 atoms close to together, how many electrons available here in 3p? 4 electrons. Okay, that means here 4 electrons are available. That means 2n electrons, 2 atoms, 2 electrons, 4 electrons, total 4 electrons. Here also how many electrons? 2n, right? 2n, that means 4 electrons. 2n means s orbital, how many electrons are available? 4, right? Total here 2 and here 2. These 2 and these 2. 4 electrons. That means 4 electrons. So suppose if you take s orbital, 2 electrons can be filled, right? 2 electrons will be filled. This is one state. This is one state. Here 2n states are there, and we can fill 2n states and 2n electrons are there. Here also 2n states are there, 2n electrons and 6n states. States means what? In p orbital, how many you can fill? 3 shells, right? 3p1, this 3px, 3py, 3pz, right? Here 2 electrons, here 2 electrons, here 2 electrons. Like that, 2 atoms are there. How many states available total? 6n state, right? Each state we are filling 2 electrons, isn't it?
Yes, sir.
Total, if you take 2 atom, 6 states are there. Each we can, using these two in s orbital, we can fill the 4 electrons maximum, right? 4 electrons, here 2 electrons maximum. But in silicon, if you take silicon, only 4 electrons available in the p shell and 4 electrons available in the, this is 3s only, 3p 3s only. Okay, now so according to Pauli exclusion principle, what is the Pauli exclusion principle? What is the Pauli exclusion principle?
No 2 atoms can have all 4 quantum numbers.
Pauli exclusion principle. Anybody? Yes. And also that is very good. Okay. And also if you take only these electrons, whatever electrons, first lower energy state only. These states only first fill. Here 4. Here also 4n it will split. Okay, 4n, here 4n. Here how many electrons are there? In 4 electrons are there, in 3s 4 electrons. That means are there, 8 electrons. That means 4 are available. 4 electrons are available. Here 4n states are splitted, but 0 electrons are available. All electrons are in this low higher energy state, 0, because always first electron So here I will explain. So here total how many electron states are there here? 6n, here 6n, and here 2n states are there. Total 8n states are there. So these two states will split into here 4n states and here 4n state. So here 4n state, in the 4n state means 4 states like this it available. Here also 4 states like this available. So what is the principle, right? Above what is first lowest energy states will be filled, right? What is that principle? Lowest energy state only first fill. After that, second highest state will be filled. What is that principle? Above, right? Above or something like that. Above, I think. So in the above principle, only electrons will be filled in these states only. In these states only. That 8 electrons. That means 4n electrons will be filled in this state. But here 4n states available, but 0 electrons are filled in this state because this is lowest energy. This is highest energy. This is highest energy, and this is lowest energy. Lowest energy states filled first. So that's why all electrons filling in the lowest energy, and in the upper energy there is no electrons. The spacing now that this empty band where conduction band, this field valence spacing between two band calling a gap. Okay, this is a little confusing. I think I will once we go through again I will explain. Okay, did you follow? Did you follow this one band gap?